8051 peripherals are four important peripherals like IO ports, timers, serial ports, and interrupts. So these are the main highlights of 8051 peripherals. Now let's get into each one of the details, like what is an 8051 IO port, how it is configured. See, there are four IO ports in 8051 core, that is port 0, port 1, port 2, and port 3. These are the four IO ports. Each of these IO ports are in 8 bit. There are 8 lines for these IO ports. Altogether, there are 32 IO lines. See, port 0 is 8 IO lines, has 8 IO lines. Port 1 also has 8 IO lines. So, similarly, total there are 32 IO lines. And these ports are accessed by a register. So, generally, if you want to reflect any IO status on the port, then you're supposed to write into the respective registers. So there are registers in the SFR special function register, so that port 0, as you can see here, so this is 80H, the address is 80H, which is address of port 0. So 80H is also address of the first bit of port 0. Second bit of port 0 is 81H. Third bit is 82H. So on till 87H. What I mean to say is there is a direct addressing for the entire port 0, which is a byte address. As well, there is a bit address which starts from 80H. So if we want to toggle a particular port of port 1, port 0.1, that means port 0 second bit, if you want to toggle, then your instruction is supposed to address 81H. Then you can do whatever bit manipulation on the second bit of port 0. Similarly, if you want to do any third bit or a fourth bit, then third bit is 82, fourth bit is 83, the last bit is 87, so on. So that is a byte address of byte and bit addressing of this port 0. Port 1, if you see, port 1 address is 90H. Port 1 address is 90H. From 80H, the 90H is port 1. Now you may say, what happens to the in between number 80, 81, 82? There are byte address for this. You have to see the SFR actually. So there are registers which are need not be accessed using bit. Maybe DP registers, or maybe stack pointers, or maybe more control registers, timer. So all these will come in this area actually between this. So what we are interested is only the port. So I am just listing out the port. But those who are bit addressable, they are made bit addressable. Byte addressable are filled in between this missing space. So 80, the next is after 87, the next address is 88. So somewhere a bit addressable register is there which start from 88, 89, so on, and finally 8F, and then a number comes 90. So that is filled as direct address for the port 1. So this is port 1 now. 90H is a port 1. If you want to make all the bits of this port 1 as high, then you're supposed to load 90H, FF. 90H, hash FF. If you load, then all this line becomes 1. But in case if you're interested to toggle a particular bit here, then you have to access with the bit address like 90, 91 bit address. Similarly, port 2 is A0. A0H is port 0 address. And finally, port 3 is B0H. So now you get an idea here how you can manipulate these IO ports by writing some values to these registers. So when you write some value to these registers, the status will appear on the IO ports. So if you want to glow an LED which is connected to port 1, you need to write to the port 1, you need to write to the register 90H, then that will turn on. If you want to make it off, you make it 0 by loading it 00 to port 1, then that LED connected to port 1 will turn off. So that is the main logic. But how the structure of the ports are arranged, we have to look in. So by default, Every IO port is at logic 1. Okay, every IO port is at logic 1. That means there is no conditional logic needed to configure the port as output. Okay, so there is no conditional logic that is required to see. In some controllers there is a separate register which is kept for controlling the direction of the port. So if you want to make it as an input, there is a direction control register which controls the direction of the line, which whether supposed to be data supposed to go out or data supposed to come in. So this direction is controlled by a separate. But in 8051 there is no direction control bit. So the port logic itself will configure the IO port as input or output. So by default, all the ports are by default every port line is pulled to logic high. That is, logically speaking, we can say that it is made as an input, but there is no condition as such. So I can even have a value for output also logic 1. So, but whenever you want to use a port as an input line, the only one condition that is supposed to satisfy is port should be pulled to logic 1. So this is the last statement you need to remember. Any port to be configured as input must be pulled to logic 1. So when you configure a port as logic input, then it has to be logic 1. But there is no condition that is supposed to maintain to configure a port as output port. Output data can be either 0 or 1, so it depends. But whenever you configure it as input, the port has to be logic 1. So just to look at the structure of this IO port now. So internal block of an IO port. As you can see, this is one of the pin, okay, of port 1 I'm discussing. One of the pin of port 1. That's called as P1.X. So how internally it is organized? There is an internal data bus bit which is connected to this flip-flop, and the output of the flip-flops is configured through a MOSFET, right? Now what happens here? So when you are writing something, a logic 1 or 0, the signal will be given to this clock. So whether it is the read or write, depending on what operation. So whenever it is write, this will be activated. Whenever it is read, this will be activated. Whenever you are simply reading the latch output, then this will activate. So now what happens here is, so this D flip flop will give the status at Q and Q bar depending on the line value here, and the MOSFET will be turned on when the Q bar is 1, when MOSFET will be turned off when Q bar is 0. That means there is a flow of current from VCC through this load L1 to the ground whenever the logic level is 1 here at Q bar. So that means this point is that this will be connected to ground, because it is on means this point is shorted to ground. If it is off means this point is connected to VCC. So that is the main logic. So it is changing the state between the two logic 0 and logic 1. Let's see how we can write a value to this port, whether it is logic 1 or logic 0. How can you write? So what happens during that? So whenever you want to write a logic 0 to the IO port, the data bus will be having 0 here, and a clock signal is generated. So this 0 will travel to the other side, which is the D flip flop. So this becomes 0 and this becomes 1. Now this is 0, this is 1. So now MOSFET is on. That means you wanted to write logic 0. This point is now at ground because this MOSFET is on. So this point is connected to ground. So you have successfully transferred the 0 to the port pin 1.x. So this is how we write. So in technical speaking, when you write logic 0 in 8051, this MOSFET is turned on and the current flows through this load through the MOSFET to the ground. Okay, so that's how you get logic 0. Let's see what happens when you write logic 1. So when you write logic 1 here, you can see that when you write a logic 1, so you see here the see here the read latch, sorry, the internal data bus will get logic 1 and a clock signal is generated. So D flip-flop will give Q as 1, Q bar as 0. Now, since Q bar is 0, what happens here is this MOSFET goes off. Once this MOSFET goes off, no current flows through this. This point will be at, it's an open circuit, so this point is at logic 1. So VCC will be driving the source current along with the logic level high to the load. So this is how the logic 1 is sent to the IO ports. So that's the main, that's how the logic 1 and logic 0 are loaded to the IO ports. Now let's see how to read a IO port pin. So there is again a condition that is supposed to maintain when you read an value from a port. So when you are configuring the port as input, the care is to be taken that pin should be at logic high. The pin should be at logic high. That means you're supposed to write a logic 1 in the as in the earlier case, like how you write logic 1, you need to do that. And once you write a logic 1, this port, this MOSFET is disabled, so VCC, internal VCC through the pull up is connected to the IO pin. Now it's a simple logic, the phenomena of electrical in electrical engineering, that anything is at higher potential, okay, I can make it 0 easily. So if you simply ground it, points become 0. So it's some kind of an AND logic that we use. So if your input is 0, this value becomes 0. If input is 1, this value becomes 1. So if you connect an external potential here, which is logic 1, there is no change, it retains logic 1. But if you connect an external potential which is 0, which we want to read as 0 itself, so it becomes 0. So that's why this pure pin, this MOSFET is to be disabled, and by making it logic 1. So you cannot do that when you write logic 0. See what happens when you write it logic 0. If you want to read logic 1, since it is 0, the AND logic becomes 0. So you cannot read it as logic 0. If you give logic 0 itself, it becomes 0. So there is a confusion. So it cannot be, so the AND retains the value with logic 1. So whichever logic you want to read, if the other bit is 1, and if you AND it, you are going to retain the logic level of the other bit. So similarly, you are interested to read the input logic. So if this bit is at logic 1, so that I can retain the input logic. So 1 ANDed with 0 is 0. We want to read 0 only. 1 ANDed with 1 is 1. So we wanted to read 1 only. So that's why the port should be at logic 1. So once you do that, whenever you perform a read operation, the read buffer pin will get activated. The data is moves to the internal data bus, and you can read the IO. So configuring the IO port as input and output. So output configuration, we have seen how exactly the data moves to the output pin, and this is about the input configuration. There is one more called read latch. This read latch is used whenever you perform certain operation, need not have to take care of the IO pin, the status of the IO pin. They need to work with only with the status of the latch. So when you are ANDing some of the bits, so then this TB2, the read latch, will be activated. Anyway, always this status is same as this, but sometime, you know what, the output, when you are configuring it as the input, then possibly this configuration, this bit will matter, not this bit. So maybe this is at logic 1, but when you configure this pin to some input which is 0, then this pin will be read as 0, whereas this pin will be read as 1. So there is a difference in reading latch, especially during the input configuration. So these are used in some of the special instructions, like in the ANDing. When you AND a value with the port, so that time this value will be read. So this is how the reading IO port as well as writing the logic to the IO level is configured. So